Now that we've described the displacement of our object, remember that our displacement vector delta r in this time interval was x of t plus t minus x of t I hat, which we denoted as delta x I hat. Now let's just remind ourselves that this distance here, that's delta x, and this whole distance from here over to there, that's what we mean by x of t plus delta t. And now what we'd like to do is describe what we call average velocity. And our average velocity depends on our time interval. So this is for the time interval t to t plus delta t, while the person has displaced a certain amount of vector delta r. And our definition for v average, it's a vector quantity, so we'll write v average. We'll use 3 bars to indicate a definition. It is the displacement during a time interval delta t. So as a vector, we have delta x over delta t I hat. And this component here is what we call the component of the average velocity. So this is the component of the average velocity. And again, as before, this component can be positive, 0, or negative, depending on the sign of delta x. And the key point here is that average velocity depends on whatever time interval you're referring to. So that's our definition of average velocity. And now what we want to do is consider what happens in the limit as delta t becomes smaller and smaller and smaller. And that will enable us to introduce our concept of instantaneous velocity.